Good afternoon, and welcome to the Blind Tinkerer's Workshop. Well, I ordered some capacitors from a place called Sal's Capacitors. That's not what the website's called, but when you go on the page. Anyways, I'm waiting to hear back from them. I ordered about $28 worth of stuff, and they have some good prices on capacitors. I have no idea what brands they carry, but I spoke to him on the phone. There was no links or anything where you can click on an order. You have to write everything down, and me, I'm a very slow writer and reader and everything else. So I called him and just rattled off the stuff that I needed. Let me show you what I'm trying to do here on this 950 while I'm waiting for parts to come in. First of all, I tacked in temporarily those 1 microfarad in parallel to make the 2 microfarad bridge. Another thing I have done also is this meter here that I bought, this Craftsman meter that I bought at the yard sale, reads capacity. And this capacitor function of this tester reads this 1 microfarad, each one of these as just about right on 1 microfarad. So they're in parallel until I get the one from Mike that he's going to make up for me. So I'm not going to worry about ordering anything else. He can set the capacity right to 2 microfarads. I'm okay on that. I checked this with this. I did all this off camera. And this is right on, just about 2. This is an 025 and it reads 0275. So that's pretty good. Now, here this is just temporarily connected in to the slider of the voltage control. Even when I'm not testing capacitors, this voltage control gets quite warm. I don't like that. This is the 5-watt control. The one that was in there is a 4-watt, but you can see how much bigger the old one was compared to the one that I bought. So either this, it doesn't say on the back, it says 100,000. This is probably a 10-watter. That's probably why. This is probably a 10-watter. This says 5 watts. I showed you that on the last video. So, anyways, what I want to do here is to put that 1,000 ohm resistor, disconnect this ground lead here and put that 1,000 ohm resistor from the grounded terminal of this voltage pot in series and into the ground. Now, thanks to one of my viewers who a few weeks ago sent me some resistors right here. They're all cut-offs and pulls, similar to what I used to have in my junk box. But luckily, here's a 10,000 ohm resistor. It's got a little band on it that says 10,000 ohm. This has got to be at least a 5-watter. So I'm going to put that in series with that. What I got to do is to put a terminal strip in there. And my chassis is getting very cluttered. Of course, I got leads in here because I'm checking values of parts. So all that. But you see the way I got the cords here with the power cord and then going through the fuse and everything. So it clutters up this place. It's not nice and neat. So I still got to get in there and change this electrolytic. There's 8 microfarad, but it's running cold. So I don't even know if that needs to be changed. I got a 1 amp fuse in here. So, but anyways, I ordered that cap anyways, along with these. The problem is, on Sal's capacitor site, they're 0.022 instead of 0.02. But these are not precision. Not these. These are 0.01s rather. I'm sorry. These are 0.01s right here. They're not precision. So an 0.01 should be fine. I hope I ordered 01s. And this is an 0.02. I ordered a few of those, but they're 0.22, so maybe with this meter I can make up and pick the one that's closest to 0.02. Regardless, they're off a little bit. That should work, but as I have been saying, there's only one range that'll work on this, and it's very strange. And all the other ranges don't work on capacity. So I'm hoping it's the cap. Maybe this cap is shorted. I have not checked it yet because I can't get on the back side of that and connect the clip lead in it. The only way I'm going to do is I'm going to try to clip this out of here, and then I can probably do that. But I really don't want to start clipping stuff out until I have parts to put in, otherwise I'll forget where they go. Alright, I put the 10,000 ohm resistor here. You know, after soldering this in, I don't write anything down a lot of times, and one of my viewers said, I think it's a 10,000 ohm resistor on the low end of this. I hope it isn't 1,000. First of all, I don't have 1,000 at 5 watt. This is the 10,000. So I removed the ground wire, the gray wire, right here, which ran from this point to the low end of the pot. This capacitor. Oh, nice. These lousy light bulbs. You just touch them and they go out. That's the second one. I just bump it and it goes out. I'll go put a CFL in there next time. So, I don't know. I hope it isn't a 1,000 ohm resistor. I'm pretty sure he said 10,000 from the low end to here to protect the pot. Pretty sure it was a 10,000. I hope it wasn't a 1,000. He's the only one that ever mentioned that. I'm pretty sure it was. Alright, so anyways, I put a terminal strip in here. The lighting is poor now because of the damn light bulb. I'm not going to replace it. I'm going to put in the CFL in it. That's what I'll put in it. I'm not going to use any more of these incandescent bulbs. It's a 60 watter. You just touch them and they go right out. Just bump them. Cheap junk. I'll take this out now. I don't need this this terminal strip because I got it connected right to ground. I had to extend the wire here. So that's a nice 10,000 ohm resistor, 5 watt at least. That might even be a 10 watter. So I left this disconnected for now because I may want to replace it. Alright, this is the voltage pot right here. See where the ground, one side of the pot is grounded? Okay, well I lifted that and put in a 10,000 ohm resistor from there to ground. But anyways, that's what I did here. And this is it right here. Now, very carefully. It's pretty cold. This pot is warm, but not quite as warm as it was. Now, with that in there, it's actually a voltage divider, and you're supposed to be able to set this to 5 milliamps. But I'm not going to risk putting one of my digital meters on there and breaking the circuit to check the current. I'm not going to worry about that. I'll put this on paper mica test. All right, this is the electrolytic. I'm going to put this on paper mica test. And I got my meter on DC. Now you see the eyes open. But just the fact that the resistance of the meter, watch what happens. Now as I turn the voltage up, see the eye closes like there's a leaky capacitor? I'll turn it all the way up here. Take the meter off, the eye opens. It only does it on the paper mica test. Electrolytics, it don't matter. And I think it's because, I'll put it on there and we'll show you. See? No difference. Because electrolytics have an inherent leakage anyways. But that's how sensitive the leakage test is for the paper and mica test, that just sticking the voltmeter in here, voltage turned all the way up, will close the eye. We got the pot all the way down. She's reading 41.7 volts. We'll turn it all the way up. And we're on electrolytic test now, all the way up. And the most I get out of that is 460 volts. Yeah, I'm on camera, okay. All right, 459 volts. Now I'll put it on paper mica test. This is still all the way up. Of course, the eye's closed. 436 volts. Always get a less voltage on that. We'll turn it down to about 200. She's pretty accurate at 200, but when you get to around 250, it's off. But anyways, we'll put it back up. 435. Electrolytic. 460, 459. Paper mica, 435. That is that. Now I read somewhere that you get a little more voltage out of it by adding this resistor in here, because it's a voltage divider. So it's warm, even when it's not testing capacitors. I mean breakdown. It can be on the bridge circuit. This still gets warm. But my capacitor meter is not working. I can't do anything until I get some parts in. All I can do is show you what it's doing now. What I'm going to do right now is I'm going to put it back on the bridge. I'm going to put the clip leads in it. And I'm going to go through all the ranges with the capacitors that I have on hand. So in order to do that properly, I'm going to put you up on a little tripod. How does that sound? Okay. You got a good view of everything. You can get to see the eye tube, and I don't know if you can actually make out the dial. Now I've got the capacitors that one of my viewers sent me that I showed you. These are brand new low voltage caps, and we're going to put them on the clip leads here and run it to its paces. Now I'm working on an angle here, so it's going to be a little hard, and I'm going to have to get my head in the way in order to look with the magnifying glass with the values here. So the first thing I want to do is try to open one of these packages here, which are not easy. These little baggies are hard to open. Try to get the plastic separated. Okay, let's see what we've got here first. We have got we get a 4.7 microfarad at 100 volts. 4.7 microfarad. Okay, so let's get the range set here now. Power factor is always down low, but the power factor on these type capacitors doesn't matter, but you still put it down to 0 anyways. Power factor is only for electrolytics. Okay, let's see. 4.7 microfarads is going to be going to be this range, 0.1 to 50 microfarads. All right, 0.1 to 50. So we're looking for 4.7 microfarads. And pretty bad, I can't even get the clips on the leads. I can't see what the hell I'm doing. Let's see now, am I on? Okay, yeah, I guess you can see that. I hope so. All right, 4.7 microfarads, capacity test. Let's move the bridge, and I'll try to keep my hand out of the way here so that all you'll be able to keep an eye on the eye tube here. We'll start down at the low end here, and we'll keep moving the dial real slow. Nope. This bridge is not working. What I'm going to show you, just First of all, we'll discharge it and just charge it through the panel here. I don't do this with electrolytics. I do this with the small things. I'm gonna put this $5 Sears meter on it. This reads capacity. My little Fluke 73 does not read. It's a damn good meter, but it don't read capacity. So let's see. We got to get this on capacity, and we're going to put the leads on. I hope you can see that. 4.7 microfarads. 4.77. All right, so we know the capacitor is good. I don't know how accurate this meter is, but at least I can read capacity with it. Okay, so we know that this is a 4.7 microfarad capacitor, but this bridge isn't reading it. Let's go to the next range. The next value is 0.1 at 100 volts. Okay, we'll get this out of the way so you can see a little bit here. All right, 0.1. I think we're on the same range. So let's see if 0.1 will work. All right, 0.1 is, you'll have to excuse my big ugly head here. 0.1, okay. 0.1 starts down at the low end of the range. Okay, watch the eye tube. No, it should have been reading before this. Nope, nothing. Nothing. So that range ain't working. 0.1 to 50 microfarads. Okay, now the reason I want to discharge it is because I don't want to ruin my digital meter here. I think you can see that. Can you see it? Huh? 101.6 nanofarad. I have a chart, and if I'm just not mistaken, that is 0.1 microfarad. I could be wrong. I'm usually wrong, more wrong than right. But anyways, we're getting a reading on that. So this EICO is not working on that range. All right, I don't have anything smaller than 0.1 in that bin. So these are some ones I got from one of my viewers. This is the 0.025 that will check. Okay. I'm going to go through these. I'll be back on camera. Okay, here's a 0.05, a 0.05 disc capacitor. All right. Let's put that on there. Okay, we're on there. When you get down to a real small capacity, we don't want to use leads like this. But I'm just showing you that this thing is just not working. So we're 0.05. 001 to 0.5. So we're on that same range. All right, now we're on the red scale, 001 to 0.5. 001, okay, we're on the second one down on the red. What the heck, what's the value of this cap now? Damn, mine is like a sieve, I'm telling you. 05. Okay, 04. 05 is right here. 04 is here. It's a little after 04. I think this is the only range that's working. Now, you see the power factor? I'm moving it. It has no effect on a paper, mica, film capacitor, whatever. Power factor is only for electrolytics. Just wanted to let you know that. Okay, this is my 025 cap. So if I put the 025 on here, this is the one that I showed you before. This is the range, I think that only range that works on this thing. So this is an 025. So we should be getting a null as we go that way, to the left. Yep. But you can see the null is a little fuzzy on the edges. In other words, like a leaky cap would be. It's not fully open. 025 right here. Right in the middle. 025. That's very close. And I don't have precision caps in here. Okay, so this range, let's see if we can get one that'll read. I'm very, very limited in capacitors. Here is a 0.01. This is one of them that I got given to me. 0.01. It's tiny, tiny writing. I can just barely read it. So 0.01 should read on this scale, because I haven't changed the scale on this. This, like I say, is the only scale that seems to be working. This is 0.01, so we should be getting a null if I go that way, provided the cap is good. Yeah. But again, I don't know if you can see that, but the null is not nice and clear. It's not nice and sharp. You look at it, it's very hard to explain, but it's not a clear null. But this is supposed to be an 01, and on the second scale, we're just to the left of 01. 01's there, we're right there. So this scale, which is the 0.001 to 0.5 microfarad scale, the red one here, second from the bottom, is working. It's not working the way it should, but it is working. And I want to reach over if I don't get zapped and put my finger on the pot over here. Lukewarm. I think that 10,000 ohm resistor is keeping the pot, you know, there's less current going through it, because that's a voltage divider. Okay, so now we're going to go check the other ranges, and I'll be back. I got to see what I got that I can read here. Okay. Here is a 3 microfarad at 6 volts. I don't know if you can see that. Use one. These are all used. But it's only 6 volts. I really don't like to put it across the bridge, but this is a 3 microfarad. So, get that out of the way so you can see. All right. We got to make sure we get the polarity correct here. Positive is this side. But we're getting, remember, this bridge puts AC on the capacitor. And a capacitor of a voltage that low could get damaged. So 3 microfarads. Let me turn this a minute so I can read this. All right. 3 microfarads is going to be on the range of 0.1 to 50, and I think this is one of the scales that don't work. Start at the low end here. Nothing yet. Nothing yet. Nothing yet. Okay, so let's take this off. No spark. All right, let me check it on. That don't read on this. So let's bring out the Craftsman here. That's reading 12.37 nanofarads. It's going all over the place here. Maybe because I got my fingers across it. Shouldn't matter at that large capacity. 11.91 nanofarads. I'd have to look that up on that chart. But this is supposed to be a 3 microfarad electrolytic. So I'm not sure about that. This could be off. Alright. And we'll turn this off. Alright, we're going to get an electrolytic now and start testing. Something a little larger. Here is a 4.7 microfarad at 250 volts. Okay, we just got to make sure we get the polarity correct now. This is the negative. 4.7 microfarad. So we got to go down to no, we stay where we are. Okay, 4.7 microfarad. Like I say, there's only one range that's working on this, and this is not one of them. All right, we start at the left. Now we're using electrolytic, so power factor does matter. But first we try to see if we get a null. So remember now, 4.7 microfarad. No. Now we're not getting a null at all, and I could push the power factor up to 15%, let's say. Because I've seen capacitors where they won't open at all unless you set the power factor up, which means that there's a lot of loss there. Okay. No. So this range is not working. Now this is 250 volts, but we're not going to test it because right now for voltage. I'm just checking for capacity. So all there is like 46 volts on the bridge anyways, AC across, and of course capacitors don't like AC except passing through, but you can't charge up a capacitor very much on AC because it needs DC. But you will have a little charge in there. So let's go and connect up this, and let's see what we've got. The negative on this side. This will be a little hard for me to hold now. It'll probably be jumping all over. Again, this is reading in nanofarads. 5.66. I can't read that little symbol on the side. It's 5 point. I don't know. I can't read that. Disregard the colored leads. I just grabbed whatever leads I had. You probably can't see it anyways. Now, let me see. Man, my eyesight. That's microfarad. That's a U. So that's microfarads. 5.65 microfarads. So we know this little guy is good as far as capacity. It's reading a little high, but that's all right. Here is a Nichicon 2200 microfarad at 50 volts. Okay, so first of all, let's make sure we got the polarity correct here. Okay, negative is on my right, or your right. So first things first, let's get the leads on the capacitor EICO bridge first. And we're on the expanded range for 2200 microfarads, which is the highest red position here before you go into the black area. So 2200 microfarads is going to be read on the top scale. So let's just see if we get anything on the expanded. Now you see what it does? It starts with a closed eye all the way to the left. Make sure I'm not only recording, but make sure you can see that. Yeah, okay. I'll move my hand because the viewfinder, as I said, is only 1.5 inches. and I just cannot see everything that's in there. So you see, look at the eye now. I'm just moving up. It's just like a linear. So if you were to have this piece of equipment and you put a capacitor on, you say, well, that capacitor is no good. Well, not necessarily. In this case, the instrument's not working. So let me try to, on my capacitor checker, well, we're going to discharge this guy because this has got AC volts on it. Let's see what we got. No. Sometimes you get a little charge even though the bridge is putting AC on it. And one of my viewers said he wanted to hear a crack on a capacitor when I discharge it. Well, I guess I can do that for you, but not on this one. This is only a 50 volt job. So we're going to put this on the other meter here. I don't know if this will read at 2200 microfarads. I really don't know. I have never used this meter on capacitors because when I got this meter, I didn't have any parts, capacitors and stuff in stock because I wasn't set up for a shop, or I had no intention of doing one. So we're on the negative lead here. The negative is over here. All right. Now, 2200 microfarads. Point. Okay. It's over limit. All right. So it's over limit. It can't read that high capacity. All right. I didn't expect to. Most of these meters will read about 100 microfarads. So, all right. Let's test another electrolytic, a higher voltage one. Here is 120 microfarads at 400 volts. Now I have several of these that were given to me, and they're all 120 microfarads, 400 volts. So we're going to charge this up, but before we charge it up, we are going to check the capacity, which this meter will not read. So we definitely got problems with this 950 bridge, and I have no idea what's going on with it. I know that it needs some capacitors, and I'm hoping that'll do it. I lost my, here it is, right in front of me. Okay, we're connected right, proper polarity. Okay. Now, before we test for voltage, I am going to put a meter on this, so I don't want to go over 400. This will put out about 460 volts. It's the highest it'll go. All right, we're at 120 microfarads. We are on the expanded scale, which will read 50 microfarads to 5,000. Let me look and see if I'm still recording. Yep, the little red light's blinking. Okay, here we go. Here goes nothing. Same thing. The eye just opens. See, that's all it does. Yeah, you got a variation here. Right about here is the widest it goes. I mean, there's no precise reading here. So this bridge is not working except on one scale, and as you see, the wedge is a little fuzzy. So, what we're going to do now, and I'm going to stop the camera for a minute, I'm going to connect my voltmeter to this electrolytic here. So we're going to put the meter on to voltage here. We'll use the Sears meter, that's pretty close. The Sears meter reads a few volts lower than my Fluke. So it could be off a little bit, but it's not to mount anything. It's only about 3 or 4 volts. So hang on a minute. All right. The voltage control here is all the way down, but I still read about 41.4 volts. Not a problem. So we got to make sure, and I'll get my chair over here to keep an eye on it, do not exceed 400 volts. And we're going to crank this up. Now, hopefully, let me just get my magnifying glass here and look in the viewfinder, make sure my arm isn't going to be in the way of the meter. Okay. Are you ready? All right, we start cranking. Capacitor is forming up. That's why the voltage climb. The eye, this is the way the eye is supposed to look when you're doing, as I mentioned before, when you are doing a capacitor. It should open up like that, unless the capacitor is defective. But that's the way it's supposed to look when you get your null. Right now we're using this as a leakage breakdown test. So we have 135 volts on there. I can't see the dial. I'm going by the voltmeter. So we're just letting it climb up. 210 volts. She's climbing, but we will not exceed 400. So as a capacitor breakdown test instrument, it works quite well. Now while that is doing that, I'm going to reach around and feel the pot again. Pot has been lukewarm. It's running a little cooler that I added that resistor in there. If I don't get myself zapped here, actually the pot is running quite warm right now. Not hot, but running quite warm. So I think there's a misprint in the book that these are not 4-watt pots that are originally in here. I think it's a 10-watt pot. Because what I bought for this Central Lab that I replaced it with, is marked right on the back 5 watts. 100,000 ohm. Okay, we're 224.8 volts right now on the capacitor, and capacitor's ice cold. I just test it by touching the back of my finger to the case, not the leads. You'll get a surprise if you touch the leads. It's raining out. We need the rain, and I'll tell you what, it sounds good on the roof of the shed here. I don't know if you can hear it. It's not raining hard though. It was earlier. Okay, we're going to crank her up a little bit more here. We just push it up. We're not sure where, not without getting my big fat head in the way here to see where the meter, the dial on the knob is reading, but that's off anyways. Now the problem is if you get a leaky cap, electrolytic cap, that could stress out that pot and could burn it out. So I'm going to reach around here again. Now I'm not grounded anywhere, I hope not. You stick my middle finger in here. The resistor is relatively cold. If it's warm, I can't really sense it. The pot is warm, but not enough to concern me. Okay, 294.3. Capacitor's cold. Let's push it up a little more here. Note the eye. And she creeps ever so slowly wider. The capacitor is forming up. What it's doing is it's charging. But when a capacitor, like a new old stock, is forming up, it's the chemical changes in the capacitor. Once they get where they're supposed to be, then the capacitor is formed up. But not all capacitors, as I said, will form up. And some of them, they actually, you heard the term dried out electrolytic. That comes from a term when the electrolytic capacitors used to be wet electrolytics. They had a wet electrolyte in them. Some of your old radios, you probably see all this white powder and everything around the cans. Well, that's when it's all dried out. Their stuff leaked out years ago. Now, what they have nowadays basically is with this dry electrolytics, but they still dry out the chemical composition of them, and everything changes and they do dry out. So there is some kind of a gel or something in there. I'm not exactly sure how they're made. I never really spent a lot of time. I did a lot of reading on it years ago, but this gray matter up here has forgotten a lot of things. So as I'm doing these things, my mind is getting a little refreshed. And it's helping you, at least wise I hope so, you people out there that want to get into this sort of thing. You got to remember that these instruments are 50, 60 years old. And you got to recap them, and I expect that. But it's very frustrating to figure why this damn thing won't read on the bridge, except on only one scale. So let me read back here again. Yeah, it's about the same. It's warm. The pot is warm, but not hot. Okay, we're going to push it all the way. Well, we can't push it up all the way. We're going to go only to 400. So we got to remember, this is the 400 volt electrolytic. We're not going over that. The breakdown voltage is 400. We do. A lot of times they'll say 400 volts or 450 volts working volts. And when it says working volts, usually you can go over just a little bit. It's not recommended. And you notice the eye? Now, if that was an old electrolytic or leaky one, this eye either would not open at all or it would only open a little bit, and it would start leaking, depending on how bad it is, start leaking at a much lower voltage, sometimes as low as 25 volts. I think that's close enough. We're not going to go any higher than that. All right. We're going to take this capacitor off. First of all, we're going to take the meter off. And then we're going to take the capacitor off. We're going to pull the leads. We're not discharging it through the pot. Now we turn the pot down because we're disconnected. All right. Now, guys, we're gonna end this video with a big bang. Please do not try this at home. I gotta put a light on that soldering station. Good thing I turned it off. I can never tell if that's on or off. What I'm about to try, do at your own risk. I am not responsible. Now you know, I'm holding this up here and letting you know that time is going by. Normally, if this capacitor was leaky, it would dissipate a lot of its charge. Not all of it maybe, but a lot of it. This is 120 microfarads at 400 volts. There's almost 400 volts on this. Right now, if you was to measure it, it would drop rapidly because of the resistance of the meter would pull it down 11 megohms or whatever the meter reading impedance is. But there's enough voltage in here. Now we're going to pop it for you, and then I'm going to make sure. Hang on just a second. I want to get the camera in a better view here. All right. Are you ready? We're in the camera. On the count of 3. As a matter of fact, I'm not even going to count. I'm going to let you hear it. Now, this camera won't pick up the dynamic range of the explosion. So we're going to lay this right across, and it'll probably, you know what, I'm not going to use that. I'm not going to ruin my Exolite. We'll use this screwdriver here. I don't want to mark up my Exolite tools here. We'll use this. We'll use this Exolite here. Ready? How do you like that, huh? It sounded better in person than on the camera. It's discharged. Thanks for watching. More to come to a computer near you very soon.